Hello, I'm Don Mackholz, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 48 for the week of December 2nd, 2020. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ, two H's. What's up in the sky this week? As our week begins on Wednesday, December 2nd, the moon is rising shortly after sunset. It's just past full phase, and it is in our evening sky almost all night long. This is a good week to photograph moonrise, and you will notice how far north the moonrise is this month. As the week progresses, the moon rises later each night, and by this weekend you will have 2 or 3 hours of darkness in the evening before moonrise. By next Tuesday, the moon will be past last quarter and 45% full in the morning sky. Jupiter and Saturn shine in the southwestern sky, a 2-for-1. At the beginning of the week, they are 2 degrees apart. By the end of the week, 1.4 degrees apart. On December 21st, they will be at their closest. Mars is high in the east these evenings, still shining, rather bright at minus 1.0 magnitude. Mars is the second brightest object in the evening sky, behind only Jupiter. We are pulling away from it, and by the end of this month, Mars will be twice as far away from us as it was in October, and it will continue to dim. Mars will linger in our evening sky, getting farther and farther away. Finally, by late July of next year, it disappears into the evening twilight sky. This happens every 2.2 years when Mars comes to opposition, as it did in October. Mars goes from being the star of the skies to being ignored to being forgotten in less than a year. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, December 2nd through Tuesday, December 8th. It all depends upon your location. This week we have 5 zones. All you need to know is your latitude. From 37 through 60 degrees north, the International Space Station will be in your evening sky all week long, sometimes twice per night. From 25 degrees north through 37 degrees north, the ISS will be visible in your evening sky, but only for the last part of this week. From 27 degrees south to 25 degrees north, much of the equatorial area, you won't be able to see it at all this week. From 35 degrees south to 27 degrees south, you can see it, and it will be in your morning sky, but only for the first few days of the week. Finally, from 55 degrees south to 35 degrees south, the International Space Station will be in your morning sky all week long. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. Now for the comets you can see this week. The positions, that is, right ascension and declination of these comets, can be found on Podcast 48, Comet Positions. You can also get the positions of these comets from Heavens-Above. Comet Howell 88P is magnitude 9.5 and crossing through the center of Capricornus in the southern evening sky. It is slowly dimming. Now is the time to get out and see it as the moon leaves the evening sky. It is plotted on podcast 48, map 1. Comet 2020 M3 Atlas is now in the northern sky all night long. See it in the eastern sky before moonrise this week. It is in the constellation Auriga, approaching open star clusters M36 and M38. It is diffuse, and the light is rather evenly spread out, so it's best seen in a dark sky. It's plotted on podcast 48, maps 1 and 2. Comet 2020 S3 Erasmus is low in the morning twilight sky, and this week you're fighting both the moonlight and twilight. It's presently about magnitude 6.5 and plotted on podcast 48, map 2. You might be wondering why I haven't discussed periodic comet Machholz 2, more commonly known as 141P. Well, I did discuss it in podcast 42, how it was recovered in August, rather faint, and it's coming into the inner solar system and should be visible in December. Well, it's December, so where is it? Actually, we know where it is, but it is still too faint to be observable visually or even with amateurs CCD. You can try for it. Eventually it will brighten to the point of being visible to us, I hope. Time will tell. This week we highlight the planet Uranus. I pronounce it Uranus so as to avoid all the humor that seems to undeservedly go to the seventh planet from the sun. Okay, the proper way to pronounce it is
Uranus.
But I've called it Uranus for most of my life. People seem to know what I'm talking about, and it's never been a problem. Maybe they should have called it Herschel. And this ice giant is in our evening sky. I suggest we look at it this week with the unaided eye, binoculars, and with a telescope. The planet Uranus was discovered by Sir William Herschel on March 13th, 1781. At that time, the planet was in his evening sky, located between M1 and M35, near the Taurus-Gemini border. He was using a 6.2-inch, 15-centimeter reflector telescope at 227 magnification. As it was between 10 and 11 p.m., the object was in his western sky about 35 degrees high. William Herschel was surveying the sky, plotting stars to measure for parallax, and what caught his eye is that this object was nebulous. So his initial response is that it was either a nebulous star or a comet. On March 17th, 4 nights later, he looked at it again and saw that it had moved, suggesting it was a comet. He continued to monitor it and a few weeks later announced it to the scientific community. After turning the data over to other astronomers, Herschel was satisfied to let others handle this object, as he was more interested in surveying the sky to learn more about the heavens than in finding comets. You can go to a town called Bath in England and stand in the garden from where this planet was discovered. I have done that. You can too. Bath, England. The Herschel Museum of Astronomy. I love these discovery stories. Uranus takes 84 years to orbit the sun and will be back in its discovery location in about 12 years, after already making a couple of circuits since discovery. It is 20 times farther from the sun than we are. Uranus is 4 times larger than the planet Earth, and it rotates on its axis every 17 hours. Its rotational axis is inclined 96 degrees to the plane of the Earth, so for some of its 84 years, it points its north pole or south pole towards the sun. The other hemisphere during some of those years sees no sunlight at all. Uranus has a lot of ice inside, water, methane, and ammonia. It has 27 moons, and in 1977, some thin rings were discovered around it. Presently, at magnitude 5.7, the brightness of Uranus varies slightly based on its distance from the Sun and its distance from us. With this in mind, let's look for Uranus this week with the unaided eye. Everyone says it can be seen with the unaided eye, so let's go out and do it. Magnitude 5.7. No bright stars around to confuse matters. High in the sky, no moon. Well, there is a star of magnitude 5.7, which is 2.3 degrees to the northwest, but don't let that interfere. In fact, that star will help us find the planet Uranus. Get to a dark location on a clear night and get adapted to the dark. Use this map, Podcast 48, Map 3. Uranus is south of the constellation Aries. Let's look at the constellation Aries. The two brightest stars are Alpha, number 13, and Beta, number 6. Those are Flamsteed Bayer numbers. You will see that labeled on the map. Trace a line from Alpha to Beta, a distance of 4.0 degrees. Once you get to Beta, the southern star, head south at a right angle to the line you just drew, and this time go 7.1 degrees. That will get you to a faint star of 5.7 magnitude. That's star number 19, and it's the same brightness as Uranus. Now continue on that line another 2.3 degrees to the planet Uranus. If you cannot see it directly, use averted vision. By looking off a bit to the side but concentrating on the area where Uranus is located. Be patient. Take some time. Tease it out of the sky. It will be easier to see Uranus in binoculars. Again, use the map, Podcast 48, Map 3. I suggest tracing it out the same way we did with the unaided eye. Start with the two brightest stars of Aries, go from the north to the south star. Then cut a 90-degree angle south and go 7.1 degrees to the star. And then finally another 2.3 degrees to Uranus. With binoculars, try for two different observations. Do you see color on the planet? And second, stars twinkle and planets don't twinkle. Do you find that to be true in this instance? Now let's turn the telescope to it. Uranus is 3.5 arcseconds in size, so it should appear as a disk. Don't be afraid to pump up the magnification. As the disk becomes larger, you might notice brightness drops off near the edge of the planet. As for the moons of Uranus, two are about 14th magnitude, much fainter than Uranus, which makes them hard to spot. The brightest two moons may be visible in an 8-inch, 20-centimeter telescope. A larger telescope is required to see two more moons. Sky and Telescope magazine posted an article in 2017 about Uranus moons and has a link to a program they developed called Moons of Uranus. This program maps the moon's position in relation to Uranus, which at least tells you where they are located. Now for the color of Uranus. To me, it has always appeared to be green, but the consensus is that it's blue-green in color or even blue. I don't see that. What do you see? Now for fun with the marathon. The Messier Marathon, where we attempt to observe in one night most or all of the 110 galaxies, clusters, and nebula cataloged by Charles Messier, is best done in late March, when all the objects can be observed in one night. But the Messier Marathon can also be done any time of the year with lesser numbers observed. This month, December, the moon is new on the weekend of December 12th and 13th. So let's set up for a Messe Marathon for Saturday night, December 12th, from mid-northern latitudes. What would such a Messe Marathon look like? A short overview. Long night, cold, and we'll miss the southern Milky Way items because they're too close to the sun to be viewed. The game plan is to do a couple of hours in the evening and get everything above the horizon, then warm up for a few hours before going back out to finish the marathon. In the evening twilight, all attention is to the southwest. A whole set of objects is just set, from M23 through M54. So try for M14 and M22, both are setting. Then M16, 17, and 18. M25 and M55. With great scene conditions, you might get all 7 of these objects, if not, perhaps only a couple. Next, we move up to M11, M26, and M75. Next, we head north for M13 and M92, then hit the northern summer Milky Way in Lyra, Cygnus, and vicinity. Then head south again for M72 and 73, M30, M2, and M15. Continue overhead and to the east for the fall and some of the winter objects. In 2 hours after you have begun, you'll have about 40 to 45 objects. So take a break of 6 or 7 hours, and get back out there a couple hours before dawn. Resume with the winter objects in Canis Major and Monoceros, the Big Dipper area, Leo, and the Virgo area. Your last object will probably be M5 in the eastern sky, but with some luck you might get M12. So there you have it, 2 sessions, a lot of sleep, and about 94 Messe objects. That's why we usually do this in March. You have been listening to Looking Up with Don, podcast episode 48 for December 2nd, 2020. I'm Don Machlz. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com, 2 H's. You can contact me at dontheastronomer@gmail.com. Once again, that is dontheastronomer, all one word, @gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's going on in the sky, prepare for the biggest meteor shower of the year, and highlight some specific objects to observe, all that and more. Thank you for listening. See the sky this week? I'll see you next week.